Welcome all for the today's presentation. So today we continue with biostatistics module, and today's topic is going to be every time this particular question is always asked. So today's topic of our discussion is number needed to treat, NNT. Okay, number needed to treat. There will always be one question on this. Okay, so concentrate on this particular topic till the end. Okay, so NNT, that is the number needed to treat, is one of the most frequently tested epidemiological calculation because it translates your statistical results into clinical meaningful number. Okay, so basically the whole purpose of this statistics and research is that we should have something which is clinically meaningful. Okay, so this NNT is important from that particular point of view. Generally, what type of question is asked? Okay, you will be given some trial related data, then event rates in the treatment group will be given, and event rates in the control group may be given. Like the prevalence of this in this group and the prevalence in that particular group, or adverse drug reaction in this group, or the cure rate in the treatment group and cure rate in the control group. Okay, then you have to calculate the ARR, that is the absolute risk reduction. Remember, you have to calculate ARR, absolute risk reduction, not RRR. Okay, that is the relative risk reduction. What we have to calculate? ARR, that is the absolute risk reduction, and then you have to calculate NNT, that is number needed to treat. So it is just a calculation here. Actually, you have to perform the calculation. Okay, so this calculations are simple, but you need to do the calculations. So what is a number needed to treat? Actually, these are the number of patients who need to receive a treatment to prevent one additional adverse outcome compared with the control group. Okay, so how many patients you need to treat, or the patients need to receive the treatment to prevent one additional adverse outcome compared with the control group. Okay, so if the NNT, that is number needed to treat, is 10, that means you have to treat 10 patients to prevent one extra event. Okay, so for example, we know the aspirin which we are using for prevention of preeclampsia. Okay, suppose we have got 100 high risk pregnant women, okay, which require, normally we give the aspirin for these high risk women. So we have got 100 high risk pregnant women. Now, if you don't give the aspirin, what is the outcome? How many patients will develop the preeclampsia? Say, for example, without aspirin, development of preeclampsia is seen in 20 patients, and 80 patients will not develop the preeclampsia. That is, the total is 100. So risk of preeclampsia without aspirin is 20%. Hope this is very clear. We are just, just going to the topic as such. Now we will look at the patients when they receive the aspirin. Okay, so if the same number of patients receive the aspirin, then how many patients will develop preeclampsia? 10 patients will develop. How many will not develop the preeclampsia? 90 patients will not develop out of 100 patients. So risk of preeclampsia in this age, in this particular group, is 10%. Okay, so without aspirin, the risk was 20%. With aspirin, the risk is come down to 10%. Okay, so now here, without treatment, 20% were patients were developing preeclampsia, 80 were not. So risk is 20%. With treatment, there were 10 patients who were developing preeclampsia, 19 did not. Okay, so treatment has prevented 20 minus 10, that is 10 cases per 100 women. Okay, so absolute risk reduction is 10%. Okay, so what we have calculated is ARR. Okay, this is one of the important step before going to NNT. Okay, so absolute risk reduction is 10%, that is 0.1. Okay, so now we calculate the NNT. The formula for NNT, number needed to treat, is 1 upon ARR. Okay, 1 upon ARR. Now ARR we have calculated, that is 0.1. So NNT is 1 upon 0.1, that is 10. That means we need to treat 10 women to prevent one disease event. Okay, so this is what is the meaning of number needed to treat. Okay, so let's see about the formula. So first, step 1 in NNT is calculate the risk in both the groups. That is the experimental event rate we will calculate. So EER, experimental event rate, that is events in the treatment group or the total treatment group, we are going to calculate. Then we are going to calculate control event rate. Okay, that is the events in the control group, okay, upon total control group. Okay, so experimental, you will have the treatment group and you will have the control group. So experimental event rate is the total number of events in the treatment group upon the total number of patients in that particular group. Control event rate will be that is CER, will be events which are happening in the control group divided by the total number of patients in that particular group. Okay, so that is why that is how we will calculate two rates. One is a experimental event rate, second is a control event rate. Then we will calculate ARR. So second step is a calculation of the absolute risk reduction, that is ARR. So formula for ARR is ARR equal to CER minus EER, that is control event rate minus experimental event rate. Always convert percentage into decimal before calculating the NNT. Okay, so the risk may be given in the percentage, so you have to convert that, like 10% we have converted into 0.1. Okay, so always convert this into decimal before calculating the NNT. So now we will calculate the NNT because we have got a ARR now. So number needed to treat is equal to 1 upon ARR. Okay, there is a one important rule. Okay, there is a one important rule which you should remember, that always round up NNT to the next whole number. Okay, suppose you get an NNT answer is 7.2, you will make it as 8. Okay, don't make it as 7. Okay, that is the number needed to treat. It has come as a 7.2. Okay, so if you make it 7, that means you need to treat 7 patients to treat or to prevent one adverse event. Is that correct? 7 patients? No, you cannot treat 7.2 patients. 7 patients will be inadequate patients. So it will go to the 8. Okay, generally what happens, we are used that 7 point up to 7.5 we convert to the lower whole number. Beyond 7.5 we convert to the higher number. No, here you convert it to the whole number because you cannot reduce the number of patients. Okay, there. Okay, so you will have to convert it to the full number, that is never round down, always round up. Okay, so NNT uses ARR, that is absolute risk reduction. It does not use relative risk. It does not use odds ratio. It does not use relative risk reduction. Okay, that is the most common mistake which is done by most of the candidates. They use RRR, relative risk reduction. What we use is a ARR. So aspirin trial. So suppose if with the aspirin, there are 20 patients who develop the stroke among the 1000 patients. And in the placebo group, there are 40 patients who develop the stroke among the 1000 patients. So first thing, we have to calculate the event rate in both groups. Okay, treatment group as well as control group. So event rate in the treatment group is 20 upon 1000. In the control group is 40 upon 1000. Okay, so experimental event rate is 0.02, control event rate is a 0.04. Okay, now we will calculate ARR. ARR is CER minus EER, that is control event rate minus experimental event rate. So 0.04 minus 0.02 is 0.02. Okay, so step 3 is the calculation of the NNT, that is number needed to treat, is 1 upon ARR, that is 1 upon 0.02. That becomes the number needed to treat is a 50. Okay, so that means treat 50 patients with aspirin to prevent one stroke. Okay, so that is what is the meaning. Another example is about the magnesium sulfate. Okay, so magnesium sulfate, if given to the patients in a group of 500, 8 patients develop eclampsia, while in the control group which did not receive the magnesium sulfate, in a 500 group, 20 patients develop the eclampsia. So what we are going to calculate first is the event rate in both groups, treatment group as well as control group. So experimental event rate is 8 upon 500, that is 0.016. Then control event rate is 20 upon 500, that is 0.04. Then we will calculate absolute risk reduction, that is 0.04 minus 0.016, that is CER minus EER. Okay, that is 0.24. Then we will calculate NNT, that is 1 upon ARR, that is 1 upon 0.024. That becomes 41.67. So we have to round up. Round up will become 42. Okay, so interpretation is that treat 42 women with magnesium sulfate to prevent one case of eclampsia. Okay. So another example we will see about the disease rate. Okay, so disease rate in a treatment group is around 10%. Disease rate in the control group is around 25%. So absolute risk reduction is 25% minus 10%. That is 15% is the absolute risk reduction. Now we have to convert this into decimal. Okay, so 15 upon 100 is 0.15. Then we will use the formula for NNT, that is 1 upon ARR, that is 1 upon 0.15, that is 6.67. So we will round it up to 7 to get a NNT. So treat 7 women to prevent one disease event. Okay. Now what is the relationship between ARR and NNT? If you have got a high ARR, okay, absolute risk reduction is high, then you need less number of patients to treat to prevent that particular risk. Okay, adverse event. Okay, so if your ARR is 50%, you just need to treat 2 patients or NNT will be 2. If ARR is 25%, NNT is 4. Okay, if ARR is 1%, then NNT will be 100%. So key concept is that higher the ARR, lower the NNT, better the treatment. Okay, lower the absolute risk reduction, higher is the NNT, less effective is the treatment. Okay, so if you have got a treatment which is effective, ARR will be more and NNT will be less. If your treatment is poor, then ARR will be less and NNT will be more. Okay, so similarly, like NNT, there is something which is called as number needed to harm. Suppose a particular intervention is harmful, the same calculation will be there, what we have done up till now. Okay, so this number needed to harm is used when treatment causes harm. Okay, so formula will be NNH will be NNH equal to 1 upon absolute risk increase, ARI. Okay, so instead of ARR, we will use ARI, that is absolute risk increase. Okay, so example is, suppose with a particular drug, the side effect is 8%. With the placebo, it is 3%. So absolute risk increase will be here 8% minus 3%. Okay, so absolute risk increase is 5%. So ARI is 0.05. So NNH equal to 1 upon 0.05. Okay, so number needed to harm is 20. Interpretations, treating 20 patients causes one extra adverse event. Okay, so now if you have got this 2 by 2 table. Okay, so in 2 by 2 table, we have got a treatment group and the control group. So event is denoted as A. Event group has got A in the treatment group and no event in the treatment group is B. So total is A plus B in the treatment group. While in the control group, total we have C plus D. C have developed the event. D did not develop the event. Okay, so experimental event rate is A upon A plus B. Okay, this is the what we have calculated. CER is a C upon C plus D. Okay, so ARR is CER minus EER. So NNT is equal to 1 upon ARR. Okay, so from examination point of view, NNT is always based on absolute risk reduction, not on relative risk or not on the odds ratio. Okay, smaller the NNT, better is the treatment. Okay, so for example, NNT is 5 is much better than NNT of 100. Okay, always convert percentage to decimals before the calculation. So 15% you will convert to 0.15. Always round up. Okay, 5.1 will be converted to 6, 12.2 will be converted to 13, 14.01 will be converted to 41. So ultimate formula, what we should keep in mind, EER is the events in the treatment group divided by total treatment group. Then CER equal to events in the control group divided by total control group. ARR is equal to CER minus EER, that is control event rate minus experimental event rate. So NNT is equal to 1 upon ARR. ARI is the experimental event rate minus control event rate. Okay, so NNH number needed to harm is 1 upon ARI. Okay. So there are few important steps which you have to remember about NNT. First, identify the treatment group and identify the control group. Then calculate EER. Then you will calculate CER. Then calculate ARR. Okay. Then we will use the formula NNT equal to 1 upon ARR. After that, we'll do the rounding up and then you will select the answer from the options which are given to you. Okay. So that finishes the today's topic of number needed to treat. Very simple and very frequently asked. Thank you.